because there was no clearly defined problem statement of what to do with the data. Now, I usually use the analogy of a problem statement might be something like, is it going to rain in London tomorrow? Now, that's a really bad problem statement because London's not defined. What is the boundary of London? Rain is not defined. Is snow rain? Is one drop of rain rain? And what is tomorrow? Is tomorrow from midnight? Is it tomorrow from 8 in the morning? So basically getting a very clear problem statement. So again, a lot of projects fail because they haven't gone through those first steps to understand the problem statement properly before they embark on the activity, and that can mean that projects can massively overrun. Access to labeled data seems obvious, but if you're doing a machine learning project and you don't have the data to train a model, your model's not going to be trained. Enough data, and again, still on subject data is obviously very important, enough data to train an accurate model. It's not uncommon for someone to say, yeah, we've got this really good project, screen fields, we want to create a model, and we want to do some predictive analytics on it, and we've got about 100 records so far to do it. It's not going to happen. Those kind of conversations, you need to tell the person to go away, come back later. To do good data science, you need good data quality, you need to have the data in a good warehousing style structure, and you need to be able to process that through. I've been to see customers where they've had all their data in XML, in a data warehouse, and they've then wanted to do data science on that, which wasn't really possible because they needed to convert all of that into actually a more reasonable structure for to go and train a model. So it is true that every data science project, you probably spend 90% of your time making sure the data is correct, enriching the data, feature engineering, all those kind of steps. And then making sure you have enough relevant features to be predictive of the label is pretty key. You can't predict a customer churn if the only thing you have is when the customer turned up. So again, a lot of data enrichment is pretty key. And to get that, you need to work with the domain experts in the field. So the customer, the people that understand if there's any additional data out there that you can bring in to be able to train your model better. So these are your typical AI roles. So the first one we have is a data scientist. Now, data scientists usually very clever people. Data scientists tend to like to just focus on the data science problem, and they're really good at that. So we normally have to build roles around that. Usually in a practice, it's a good idea to have someone in the practice that is a reasonably good data scientist. Now, it's okay to, if you're a software house, to cross-train and bring people up from database DBAs or database developers or programmers into starting to do data science. But the data science is one of those subjects where it can go really smooth sailing, and then suddenly just a slight change in requirements can throw a project out massively. So usually we say you want someone that's a good data scientist in your consultancy that can help deal with those problems and identify problems that occur. And then we have ML engineers, so data scientists like to focus on the creating the model. Machine learning engineers help to help operationalize that model, help manage maybe your Kubernetes clusters, your databases, if you're taking a model and deploying the database. We have our business analysts that help understand the requirements, help help understand the domain. IT, obviously, we always need IT for everything. And then we have our AI architect that helps gel everyone together. So all of these are pretty key. Now, obviously, if you're in a small consultancy, you can cross over some of these roles. So you could have a data scientist that's also a machine learning engineer. But these are the kind of key responsibilities you need within a machine learning project. Now, this usually scares people when they're starting a practice, because depending on the problem, there can be a very thin line from being very easy to being very complicated. For example, in Azure, we have things like cognitive services. Cognitive services are just API calls that you can make, very easy just to stick into your project, very easy just to add to anything, really, and then you have AI and machine learning there. They do pretty well, but there are some things that they can't do. If you find that you can't, you've got a problem that doesn't hit the things that cognitive services can do, i.e. you have to go off and start developing your own, that can take a project from a couple of weeks to a couple of months, because you then have to go off, train a model. Might be a complicated model, depending what it is. Might be a deep neural network. So, and then you might need all of those data scientist skills to be able to get you there. So being aware of what's possible is pretty key in being able to anticipate how long a project is going to take. So in this graph, we just say, cognitive services, we have very easy to implement, could take a few minutes to implement. We have custom cognitive services, we have the visual designer, so drag and drop. We have things like bots, AutoML wizards, which kind of takes some of the pressure off having a dedicated data scientist somewhat, and then there's obviously, you might have to go off and do custom machine learning. So typical kind of customer concerns that we see out in the field. So if you're trying to get a customer to do some machine learning, these are the kind of people that might try and block it. So skeptics will think it's too good to be true. It's often we will go and do some demos of some of our machine learning capabilities, and they'll say, oh, it's all smoke and mirrors, you're using specific data, it can't possibly be this good. So that's sometimes a challenge. And some people don't really understand data science and think if it's not 100% right all the time, it's useless. So being able to manage those expectations for those skeptics around data science, and normally you handle that by doing demos, maybe taking some of their data, processing it, showing how good it is at running with their stuff. People feel threatened. We live in a world of hypercapitalism, and what that means is job roles are changing over and over and over, especially the kind of stuff that we have in the data science field, where we're automating a lot of things. Roles that are being potentially in danger are things such as drivers, because we have things like automated cars. We have things like cognitive search, which takes away a lot of the pain of searching through documents. So things like law clerks, those kind of people, some of their roles could be potentially being taken away. So that's something that is possible. And then we have end of current business model. So if you're an insurance company and we have driverless cars, that's the end. You have to completely change your insurance model, for example. People that are worried about loss of decision control. So an automated process, is that going to take away your ability to make decisions? We hear horror stories of people that have been fired and they can't come into the office, even though, being fired by an automated system, and they can't come into the office, even though they haven't actually lost the job, because all the systems are against them and they're unable to work. So obviously you don't have to create systems that automatically make decisions about people. We'll talk about some of this in the legal stuff as well. We also get people suspicious or anxious of technology, the motivations behind it, things doing representational harm. We've had this ourselves. We released a bot quite a few years ago now called Tay. The Tay bot learned by people talking to it. We hadn't thought that some people from 4chan would start talking to Tay and corrupt it. So, and after a day, Tay turned into a anti-Semitic, Nazi, over-sexualized bot, a really big marketing problem for us, so we killed the bot. So yeah, big problem in terms of causing reputational harm to us. So we killed the bot, but regardless, it was a good experiment in pure data science, because it did what it should have done. It learned from people. But anyway, you will get people suspicious of motivations, suspicious of representational harm. We have some things in place that will help with that, which we'll get to. And then the final one, people say, it's not for my industry. Data science works for every industry. Normally, if you have someone with this kind of objection, you just show them their competitors who are probably doing data science as well. Okay, so we have legal and ethical implications of machine learning. So there's lots of new stuff that's happening in this field. It used to be a bit of the Wild West. You used to be able to do whatever you wanted within machine learning. We tried to control that. We set up some organizations. We had set up the partner pledge, which made sure all of our partner ecosystem did ethical machine learning. There are now governmental bodies have started to catch up, and so we now have some new laws and regulations coming in. The key ones to, let's skip over this one, key ones to No, it's GDPR, which you're probably all familiar with GDPR. Within GDPR, basically it says that any decision that affects a person, any automated decision that affects a person has to be explained. If you've created a deep neural network that decides if someone is able to get a loan or not, that deep neural network, and that person comes to you and says, why didn't I get a loan, or why did I get a loan? You have to be able to explain the decision process of what that deep neural network did as to why they did or didn't get a loan. In line with GDPR. So a lot of the stuff that's happening in data science at the moment is tools to make explainability. So we have an API that lets you do model explainability that you can use, so you can fulfill these requirements of GDPR. We also have the EUAI Act, which is coming along. If you want to read it, there's the URL at the bottom. It's only 45,000 words, so nice light reading you can do over lunch. It's some of the kind of key things that are interesting. You can't do subliminal messages or trying to convert someone's behavior. You can't disadvantage a vulnerable group. You can't, public authorities cannot use cameras and stuff to identify people. And also, public authorities can't do a social scoring system. If anyone's seen that Black Mirror episode about social scoring, that's exactly what this act is trying to stop happening. So we have, at Microsoft, we have quite a few tools at our disposal that you can use that will help you understand the harm that you might be doing when you do take on machine learning projects. So we have harms modeling, which is a framework for understanding where you could be creating harm, because there's not just harm, it's not just representational harm to yourselves as an organization. It could be harm to your customer. It could be harm to a third party. It could be harm to someone that you hadn't even thought about. So this helps you understand that. We also have another tool called commitment jury. So we try and ask anyone that's doing data science to make sure they have a diverse team. But a commitment jury basically brings in more people just to understand if the thing you're doing, if it's a bot and the way the bot talks might cause harm to somebody that you hadn't potentially thought about. And then we have a card game called Judgment Call that you can play. Put your problem out, play that game, and it's a nice fun way of just thinking about your problems. Right. We have Fair Learn, and I'll skip through a few of these. Architectural, make sure you have the architectural, make sure you have good architecture and the ability to make the good decisions to choose the most performant tools and technologies. I'm not going to run through all these. This is for a session that's not 20 minutes long, but we have lots and lots of tooling in Azure, lots of ways to operationalize those technologies. So making sure you know which tools are the right tools for the job is going to save you a lot of time and effort in your practice. AI is one of those technologies that fits quite well with other things. So if someone is developing a data warehouse, machine learning is a natural thing to start fitting on the end of it. If someone is thinking about machine learning, then maybe they need to have a data warehouse. So all these technologies interact with each other, and you can and on your machine learning practice, you help by building in with the other practices. Okay, so relationship between the domain experts and the data scientist is pretty key. Like I said before, most projects fail because they don't have this close relationship. There's probably some data. If you give a data scientist some data and you don't explain the data, they probably might get the wrong end of the stick. They might not realize that there's additional data they can bring in. I've seen projects go from 0.8 accuracy to 86% accuracy just by letting the data scientists actually understand what those fields are. So pretty key. Here's an example. This is quite a good example from US. So in a pool of 36,000 office workers, people who take short breaks at work are far more likely to die of cancer. Now, without domain expertise, from that problem statement, you might say, okay, we don't take breaks at work. Maybe we don't even take long breaks now because breaks are obviously detrimental to health. People won't be going out to the gym in those short breaks. They're probably going off having a cigarette. So having that understanding of the deeper picture is what you need. Because if you didn't have that, you might start making wrong decisions. Okay, so let's talk about, this is my kind of cheat sheet of things to consider when you're building a consultancy and you're taking on data science problems. So first thing, it's pretty important to target existing customers. Data science is one of those things where it's different to standard IT projects. A normal IT project, if it's like, let's create a website, there'll be a website. Let's create a data warehouse, there'll be a data warehouse. Might be rubbish, might be amazing, but there'll be something tangible. If a customer comes to you and say, we want to be able to predict X, Y, Z, they might spend a load of money with you, and at the end of it, you might go, hey, we couldn't predict X, Y, Z. It's not possible. So having that good relationship and setting expectations beforehand is pretty key. Helping the customer see the possibilities and benefits of AI. So this is where your technical sales teams come in to help do envisioning, to help understand. They've got a problem which they may not have thought of as a machine learning might be a solution. A good example might be, we used to see this a lot with IoT, where they would put in car parks, they put lots of IoT devices on the parking spaces, and that works, but it's expensive to have all those IoT devices, whereas you could solve the problem with machine learning by just putting a camera up in the car park, and then that can identify which spaces are filled and not. So much cheaper solution in terms of the hardware. Okay, so help the customer see the business impact, the business benefits of using AI. We see a problem with new consultancies where they just go, this is so cool, this stuff, but there's no business benefit from it. So don't really focus on the coolness of things. Don't overpromise, be realistic. Make sure your customer's got the data. Make sure the problem is in scope of what is happening. Always managing those customer expectations, because an AI project is different to normal projects. Make sure they don't think it's too good to be true. We talked about it earlier, and be clear about AI and ML. So what is off the shelf, and at what point does something that takes almost no amount of time suddenly turn into a good few months project? So I am out of time, so I will leave it there. Do we have any time for questions? Okay. So if anyone's got any questions, you can come see me on the Microsoft stand. I'll be around here for the next 5 minutes or so. But thank you for your time.